And oh, ok, tout va bien. Faut que je recorde aussi, moi. So now we are going to see how we can handle the different variants for an enum that we have defined. And this is going to be done thanks to the match pattern. And basically, this will allow us to match every single variant and handle every single variant with different code. Interesting things about the match pattern is that it needs to be exhaustive. So you always need to handle all the possible cases. Even if like you define a catch-all pattern at the last step of your match pattern, it means that you agree. Oh, sorry, I have a call. Okay, not important. So even if we define a catch-all condition at the end, it means we are okay with handling all the rest of the cases in this way. And yeah, just we can already dive into it. So this is like the shape enum that we have been using so far. We define now a method for this enum, and this method is the area method. And of course, if our shape is a dot or a circle or a rectangle, the area cannot be computed the same way. So it means that we need to know for which we need to be able to handle each variant of the enum separately. So how does it work? The match construct. You put the match keyword, then you put the value you want to match against. So in this case, this is self, which is a shape. And you list the different variants. So one variance might be shape colon dot. And in this case, we return 0 as area because the dot has no area. In case this is a circle, and this is where it's important to understand destructuring that we have seen so far in the previous lessons, is that actually this is somehow destructuring the enum variant. So we get access to the radius so that we can actually do some computation on it. So here we see that R, and we could have called it like, I don't know, whatever, B. This is not important because this is some kind of, could be a variable name. You can see it as a variable name. What is interesting is that we see that it's a reference to a U32, and this comes from the fact that we are matching a pattern of something which is itself a reference. So it means when we access the fields of these enums, it's going to be references and not owned values. So this is how we compute the area in case it's a circle. So we dereference B because it's a pointer. So if it's a reference. So if we want to get the value pointed by that reference, we need to dereference it. And we do the computation of the area. And finally, for the rectangle, if we want to get access to the width and the height, we have to do like this: rectangle, width, height, and this takes some, this is going to be our variable names, and we can do the computation based on those values. interesting thing is that we need to do some casting because everything is defined as U32 in the enum, and the area is going to be a floating number. So at some point we need to cast to F64. Okay, this is maybe a design issue. We could have put like just F64 in the enum instead of casting, which is not optimal. Would be more accurate to put some F64 everywhere instead of casting. And so let's verify that what we have just did is actually working. So we instantiate a dot shape, a circle shape, and a rectangle shape, and we call area method for each of them. And let's see if it works. And yes, it seems it works. I don't want to compute by hand the area of the circle, but I trust the implementation. And so we have handled every separate enum variant in a single method thanks to the match construct. So yeah, this small paragraph is just to explain and maybe make you realize, if you haven't yet, that this enum and match pattern can actually help you to achieve a lot of concepts that you may be familiar with in object-oriented programming. So these are some similarities that it shares with inheritance. It means you can handle different types, and those share common behaviors. You can add method to the enum that works differently for each variant. That relates, and it provides some kind of runtime polymorphism, because every variant, I mean, you can have an enum that can handle different types, of course. And these are some differences. It means there is no shared base class from which you can inherit. I'm going to sign this. Thank you. Question. There is no dynamic dispatch, so like a lot of things happen at compile time. You cannot like turn a dot into a circle, something like that. This is not possible. You have to instantiate a new variant. There is no method overriding. This is like type safe because the compiler can verify everything at every moment. And this is like also a lot more efficient in terms of performance, because if you think about it, inheritance and so on has a huge cost because it's like dynamic casting and things like that. So it's always checking dynamically that the data you are pointing to is valid and so on. While here is like everything is resolved at compile time, so it should be much more efficient than like a similar pattern that you would implement with traditional object-oriented programming. So here, let's see the data exhaustiveness of pattern matching. Which means that we always need to implement in a match statement. We are always it's always mandatory to handle all the possible case. So let's try to uncomment one of them. I commented the circle, and what the compiler tells me, missing match arm, circle is not covered. So it basically requires me to implement this method, the case where the variant is a circle. Otherwise, the code will just not compile. This is not a warning, this is an error. So just checking. Okay, I'm talking about it after. So here we are calling the print shape method for every different variant. So dot should tell we are all shapes, but I'm a dot. Circle should tell we are all shapes, but I'm a circle. And the rectangle should say we are all shapes, but I'm a rectangle. Let's verify that. Toto, okay, that's what we got here. We got some other message after. So now let's say I need to implement a method that only one variant can satisfy. I don't know, print only dot. I define a match statement. I take self. I define the implementation I want for the self variant. So it will say I'm a dot. And either we define every single variant with the same message. So like I'm not a dot, or we don't care about the others. Or we can use like the catch-all notation, which is like underscore, the arrow, and then the code block that we want to implement. And actually these two parentheses are useless. And yes, but these notations, sometimes it's interesting and sometimes it's not, because what does it mean? What happens if I add a shape somewhere? I add a new shape here. I don't know, the square. So here we see that it's interesting. It raises an error. It tells me like the square is not handled. But here, since we have like the catch-all, it goes through. And sometimes it's a desired behavior and sometimes it's not. So if you really want like all the cases to always be implemented like explicitly, a different notation that you could do instead of using the catch-all would be to do self circle or self rectangle. And I think the notation for struct is a bit weird. But again, this is not like a notation one should use a lot. Square, self.square, and then the implementation, I mean, what we want to do for this one. Ah, damn it. So this way we are more explicit in the way we deal with the default case. It requires a bit more code, but actually we know what it defaults to. And if I want actually to create a new shape, I don't know, triangle. This this implementation with the match statement will not be happy because I'm not handling the triangle. So these are two different ways to implement let's say, to implement the same thing. But this is not going to be always possible, and the reason is I'm introducing the match statement only now, but this is something you can use with a lot of things. You can use like the match statement for integer, like checking that an integer is in a range. You can have like let I equal, I don't know, 42. This is possible. You match I and you have an implementation if if it's between 0 and 10, you do println in 0, 10. If it's 42, you say magic number. And you see in this case, it tells me, okay, non-exhaustive pattern. There are a lot of integers you don't handle, right? And in this particular case, this is where you cannot like just set every integer in the match pattern. So you would have to default with the catch-all because it's not possible other way. So this is just an example showing that the match statement can be used like with a lot of things, not only with enums. It works with integers and yeah, with variables. With strings, you could do match statement with strings. Maybe I'm talking about this later, so I'm not going to. You could do something like this. Match S, and if S equal test, do something. But again, I need to handle all the different cases. You see, again, non-exhaustive pattern. So for the one I don't want to handle, I do println. I don't care. So this is what is very powerful with the match pattern. Always need a default case or a default implementation. You can match many things, integers, enums, like it's very, very, very frequently used with enums for handling every variant. And let's continue. Print only circle. Yes, that's what I said. Actually, this is what I explained, like being exhaustive versus being b- versus using the catch-all. So yeah, you already know everything about that. So I will remove that because it's not like interesting. This I will default to this. Any question about the match pattern and enums? No? Everything clear? Not too confusing, this match pattern? Because for me, it confused me a lot, like when I learned. No? Okay. Okay, this is what I just showed previously. So pattern matching can go beyond enums. So in this case, we handle different integers and print a different message based on the integer. That's maybe a more complete example than what I showed previously. So as I said, we can check for integers being inside ranges, being specific values, but always having a default implementation, a default case. That's what you have to remember. And again, all this goes in this logic that Rust is really fighting against unexpected and how to say weird behavior that you can unintentionally put in your programs, like if else not being handled, and at some point you don't understand why your program is behaving like that. So by enforcing all these default case implementation and so on, really forces you to basically to handle every possible scenario for your code. So what is in this example? So here again, this is the same kind of example with a match pattern. We are using a match pattern to match a string, to match against a string. So yes, this might, I don't know if you see all possible usage of this pattern, but it's something very powerful. So here we just like created a function that answers to two questions, and to any other question says I don't have an answer. So for the first two ones, we should get an answer, and for the last one, we should have I don't have an answer. So, yeah, why the first one tells me I don't have an answer? Maybe there is a typo.
Yes, question
Aha,
line. Yeah.
yes, you found the bug.
Before
Okay.
Copilot or
No, this was not a copilot. I guess I had the arrow at the two places, and I just fixed that one place. So, yeah, everything clear about this? So make an enum which can carry either an int or a string. Then make a function named tell me, making such an enum, taking such an enum as parameter, and printing the range as above if it's an int. Otherwise, answering to the question as above. Printing the range, okay. So I mean printing the range like this. Basically, what I want, it's like a combinations of the last two stuff, but with a specific enum. Everything in an enum. So I would do something like this. What was the integer type that I used above? I32. I32. So again, the enum, the variant names are whatever. We can use whatever we want. It has nothing, it doesn't need to be very related to the data it carries. This is always better because it makes more sense of your enum. But I mean, you can use whatever naming you want. Then we implement the method. Damn it. What the hell? Okay. So should not be very complex. Match self int I, and we can be super lazy and copy paste. That's what I'm gonna do. Again, it tells me I'm missing implementation for string. So let's do it. Then super lazy again. Copy. But there we are going to have a bug. I tell you. It's going to complain, no? Yes. I was expecting that. Why is it complaining? Found reference to static string. Okay, because it's not happy because we are trying to compare a string reference with the string slice, which are two different types. So maybe if we do S as string, it should work because the two are string slices. S as str return the string slice out of a string, and this static literal string, I mean literal string are always static lifetime string slices. So we compare apple with apple, string slice with string slice, and the compiler is happy. And if the compiler is happy, I'm happy. So now we have combined the two stuff that we have seen above, and we should be able to to call the tellme method on each variant. So about int 42.tellme. I'm just like abstracting like the variable creation. I'm calling tellme directly out of the about enum. This works. It should tell me, okay, 42 is the answer to the ultimate question of life, the universe, and everything. It works as I want. And we can get the reverse about, oh, we could have called this question. And we can copy This, again, we need to create a string because that's what we expect. Why is it complaining? What did I do? Why aren't you happy? Ah, okay. Because I'm not using the stuff, so that's why he is complaining. But now the compiler is happy. And okay, it just replies to the question. Maybe I should just put the println in between. Okay. So anyone stuck with this, or is this okay? Is this clear what we can do with enums, how to use match pattern, at least with enums, and maybe already imagine what you can do with enum? But yes, remember enums are everywhere in Rust, and this is very, very important. And I think that's what we are going to see as well in the next chapter, if no question. And the next chapter is options. Options is something we have been talking about in the first chapters on Friday. But before going into options, I just wanted to introduce very, very little about generics. So generics, it's a way to define an implementation that is going to apply to different types. You can see it as a kind of template. So it might be an enum template or a structure template. So what is the idea behind generic is that we have to remember Rust is a language which is strongly typed. And as a consequence, when you have a structure or a data structure, it needs to be bound to a given type. Of course, if you want to have like a vector, we have seen the vector needs to have a type, right? So if you want to create a vector of U32, a vector of F64, any kind of vector, you don't want to define every single implementation of a vector, right? This is super boring. So the way to do it is that you do it through generics. It means you define vector for a generic type, let's call it T, and then the compiler on the fly will, at compile time, will generate all the implementation and all the functions for a vector of the type that you are using. And this is what generics are. We are going to see much more into details in next chapter. But what I need you to understand right now is that we can define a generic enum this way. And I'm intentionally defining an enum here, which is very, very, very close to the option enum, which is enum of the standard Rust library. This is just to show you what it looks like on the implementation side and how we can actually use it. So here we define an enum called optional value, and we define it for a generic type T. So an optional value, that's what we have seen in one of the examples last week, is either something or either nothing. This is how you can seal, I don't know, like a optional parameter or something like this. And this is also something you will see everywhere in Rust. So this is how we would implement a optional value. So what we do here, so we define this enum for any type T, and it wraps the type into some variant, and this T will be replaced by effectively by the type we are using. This might be super confusing as well, coming from other languages, even though some languages are pushing towards generic too. I guess there are concepts like close to generics in C++, in Rust, there are generics, in TypeScript too, there are. So yeah, it's basically defining something for any type T. So it means when I'm using optional value with a string, it creates me an optional value with a string. When I use an optional value with a i32, it creates me a type optional value i32. We have to think about that this is up to the Rust compiler to generate all the code behind this. It's exactly the same in your mind. You have to replace that in your mind, that it's exactly the same as having an implementation of optional value for strings, an implementation of optional value for i32. It's just that it's transparent to you. It's like the Rust compiler does it for you. And that's what I'm just saying here. This is exactly as defining, this is replacing actually T by a string. If you would say that, this wouldn't produce valid Rust code, of course. But this is what the compiler does under the hood. And now it's where it might become confusing. It's when we want to use the non-variant. Let's remove that. If we do that, the compiler is not happy. And why? Does anyone has an idea why the compiler is not happy about this? This is a tricky question, a bit hard to answer. Does anyone has an idea?
Because none is not a type.
Yes, partially. There is some type and there is something related to none. It's because actually the compiler, you ask him to say, okay, optional value, I want none, but for which implementation of optional value, basically? You want it like for optional value integer, optional value string, optional value whatever. It actually now you cannot just use this variant without anything else. It's because it just doesn't know for which implementation actually of generic type you want the non-value for. So you have to be explicit either by putting the type here and saying maybe i32, like that it's valid because it's going to give the non-value of an optional value I32. Or you can put it, if you don't put it in the, we can do like that. These are two equivalent notations. And these are, this is like a notation. Yeah, both notation you should remember. This is like for providing and giving a implementation for which generic basically. You are just instructing the compiler to say, I want the non-variant for this implementation of optional value. So optional value I32. And you say exactly the same thing here. And this is a notation that you will have to be familiar with because it's used a lot, especially for vectors and structures like that. When you are dealing with collections and so on. So what might be interesting to see is, okay, now this is like the non for a string, the non for I32, non str, non I32. Do you think we can compare the both?
I don't think,
Why?
because it's not the same type.
Yes, sure. We cannot, even though like they look the same, they are not the same because they are not like the known value for the same type. So if I try to do I cannot do assert. I could do assert if I derive partial ek and ek. Okay, known I32. So let's try to assert ek. Oh, none and none. And yeah. And that's exactly what you said, Tizio, is that these are just two different types. Even though, I mean, the variants of the same name doesn't mean they are coming from the same type. This is not too confusing. Yes, no. Because this was like also source of issues in like the previous iteration of this training.
Focus on it again with people.
Yeah, maybe think about it, and it will become maybe more clear if you step a bit back. So this is just it was just to show you like a bit of generics and why. It's because the option enum, the one in the Rust standard library that we can find there. If we type option, std option is exactly that. That's why I wanted to just introduce generics, is because they are actually here. And this type is something you will see everywhere in Rust, so you need to understand it. And why? It's because like everything, a lot of things are optional. Like, for instance, when you want to get, for instance, an object in a vector, if you go out of bound, it can be either none or something. It can be whatever items in hash map. It's either something related to the key or none if it's nothing. So this is like a structure you will literally see everywhere. For instance, what do I say here? So yes, it's the Rust way to handle a value that might be present or absent without using null. And that's what actually cause also a lot of bugs in C and C++, like the use of null is like the source of thousands of issues. So yeah, why do we need to use null? It forces you to handle both the cases, as we have seen. It's more clear than having to rely on stuff like -1 or not found or stuff like this. Special values, let's say, for a type. This is the tricks that you do in C, for instance, like if the parameter has like some weird value, I consider that this is nothing. So this enum is just to solve all these issues. An example of a struct of a user struct that you might have in a database, for instance. You say, okay, identifier is something I require, a password is something I require, and an age, okay, I decide it's optional because in the end we don't care. So this is the constructor of the user struct, takes identifier, password, optional age. The function has age, which returns a Boolean, and that returns true if age is actually something. Is a method that you can find on the option. If you look at the enum definition in the standard library, returns true if the option is some value. Okay. And print, it's basically a function that println information that's a identifier, password, and will show either true or false in function of if an age was specified or not. So now we create two users, one called Toto and one called Joe, one with an age of 42 and the other with an age of none. And this is like a very simplistic use case of optional value. And you see it become like super easy to handle very specific case, and especially where you need to have, yes, either basically just optional values. And as we have seen on Monday, yeah, maybe I will see that later. Map. Yes, there are some unwrap. So we are going to cover unwrap after. No issue. Haha, interesting thing. We have some specific conditions and control flow conditions that can be used with anything basically, but it's more obvious when speaking about enums and errors, as we will see later. So here is what we have seen for the match pattern, right? So we create an option with a i32. We match on that option. If it's something, we print the value. If it's none, we do nothing. And there is a much more concise way to do the exact same thing, which is the if-let construct, the if-let control flow. It's basically a combination of a if and a variable assignment, and leveraging destructuring as well. So this is why we need to put everything together now. So if we manage to destructure O into some I, we println I. And if it's none, we just don't care. Okay, so if-let works with any enums, but you will very likely use it a lot to handle option enums. Yes. So yeah, it works with any enums, but this kind of pattern you will see like a lot. Interesting is that it doesn't really force you to handle the known case in this case. So yeah. But this is much more concise code as this. So yes, just be cautious with this because you don't benefit from the default case handling. Is everyone comfortable with this notation, or is it causing some troubles? So you have to read it. If we manage to destructure O as a some I, we do. Okay? So now we have very powerful and useful methods that you can use over options. So again, if you want to know all of them, feel free to look at the option enum documentation in the standard library. We are going to cover one of the most important one and the one you will see and use a lot, which is the map one. So what does the map? It's actually taking the result of an option and mapping the result to something else if and only if it's something. Okay? If it's none, it's just staying as none. So uncommon below code, tuk tuk, and we see what it does. So look here, we take optional count, which is OS is optional string, which is some hello world. So optional string, it will show some hello world. Optional count will count the number of bytes in the string by taking this and mapping the results to s.len, so the length of the string. And here, basically what we do, we try to do the exact same thing, except that we use the non-optional option variant instead of something. And let's see what happens. So so optional string says hello world. optional byte count here says sum 12. Map actually maps and wraps it again to a new option. Okay, so that's basically how you can always have none at the end. And of course, the non-string, since it was not something, some variant, the s.length just don't get called, and the result is none itself. Stays none. So what is interesting is that if we look at the prototype of the map function, here, so yeah, notation is a bit ugly because it makes heavy use of generics, but what it says it takes self enum. F is a function. It's fn once. It's actually a how is called? Ah, damn it! Not lambda function. Closure. It's a closure that takes a type T and returns type U. That's it. It can be whatever. And the results of the map is an option of type U. So basically what it does, it applies the closure and wraps the result of the closure in an option. That's what it does. So what I want to say, you call an option dot map, you get another option, meaning you can actually chain as many map as you want. And that's what we are going to do right now. I take that string, I map the first time s.len, and I map the second time, I take the len, and len multiply by 2. Okay, I could have done that in a single map, but this is just like to show. Yeah, Raphael is having some issues with translating Python into Rust, right?
Oh yeah, no, it's just it's just me. Like I have like to me like you're creating objects all the time, and that's weird and bad, but it's not Python, so I need to stop thinking that way. Anyway, it was just a side comment. Like yeah, it's fine.
But
It is purely me having to figure that out and stop thinking that way. But like it's fine.
But yes, I understand that it can be source of confusion, but in the end, when you get used to it, it makes a lot of sense.
Oh no, absolutely.
It's just a mental barrier.
Yeah.
I had some as well, so I kind of feel what you are living now. So yes, so we could chain like map as many times as we want, and even some most of the time, like the compiler would optimize all this out and would be producing like very, very efficient code at the end. Haha, we are coming to unwrapping options in Rust. So unwrapping, what does it mean? It means extracting the value from inside the option. So an option T, you have to see it as like a box that contains a value, or the box might be empty, none. Unwrapping is what is taking the stuff out of the box. You unwrap from a gift, for instance.
What's the difference from the
destructuring? Destructuring doesn't extract the value. Let's see that the difference. You can achieve the same goal. Actually, the safe way and the nice way to handle enums and option is to actually do iflet and handle the case like that. But sometimes there are some cases where you might want to unwrap, and I will show you some examples because it's produce shorter code, and in the end you don't need to do pattern matching and destructuring. Sorry. But yeah, the only difference is like there is basically no really difference except if you really use unwrap, the difference is that unwrap, if it's none, it's going to panic. So unwrapping, just like using unwrap call like this is pretty bad thing to do, as we have seen last week. And also the difference is when you unwrap, you take ownership of the value that you unwrap. So here we're not going to see the difference really because we are dealing with stuff on the stack, but it means that you cannot reuse the option after. While there, I think we can still reuse the option even though we unwrap. Let's try. Or maybe I'm saying bullshit, I don't know. Yeah, this works. And this works for the only reason that this can be copied out. We don't take ownership over the type here because of the ownership rules and stuff we have seen so far. But if this would have been a more complex type like a string or a, we can try it. This wouldn't work, right? Oh, yes, it works. It does work. Why? I don't know. Okay. I have to figure that out. Okay, whatever. So here we have an enum option value. It's some integer 5. We unwrap it, sorry. We get the number. And as we see, unwrapping is what is exactly the same thing as doing that. It's match some number. If it's some I, returns I. If it's none, panic. Panic, this is like the stuff generating a stack trace, and this is a macro aborting the Rust program and generating a stack trace. So let's see, what does it do? Exactly the same thing. Unwrap number 5, manually unwrap number 5. Okay. Now let's try to do that just to see what unwrap does on a non-value. Boom. Big stack trace telling us that we unwrap on a known value. So important rules, avoid unwrap in production code as it can crash your program. And prefer pattern matching or unwrap variants. And one nice unwrap variant is, for instance, unwrap or which is this one, unwrap or. Unwrap or gives you the opportunity to provide the default value in case you want to unwrap something which is none. Unwrap or 42, and in this case, it's not going to panic. So here we should have 42. Okay, because we try to unwrap none. And the other interesting variant of unwrap is unwrap or default, which takes no parameter and just returns the default value for the type. Assuming the type you want to unwrap for as a default value in a default implementation. In this case, I32 default value is 0. And basically all the numeric types, they have a default value of 0. So we can safely use unwrap or default. So in terms that, okay, either unwrapping, handling with iflet, handling with match, end up being the same in the end. It's just a matter of concise code. It's always like shorter to write one line rather than 3 or 4 lines of iflet. And maybe even like the Clippy will tell you when you try to do something too long. Let's try. If I do match of number, iflet. No. Look, even Clippy tells me iflet can be simplified by unwrap or default. So it just means in the end it's the same. It's just like it's more concise to write it like unwrap or default rather than or even maybe if I maybe even smart if I do that he would propose me unwrap or default. Look, it is very smart. So yeah, in the end it's the same. It's just a matter of being more concise in your code.
But is there a try catch?
No, there is no exception in Rust. Yeah, I see your eyes. There is no exception.
Because everything is safe and handled.
Yeah, there is absolutely no exception.
It's not possible.
Or it panics. But yeah.
No. This is very bad implementation. If the code panics, I mean, this
Oh,
is
no, I mean,
there is some.
It's absolutely. It's just, it's again the use of being in Python and being like, well, I'm going to try except finally and just handle my thing this way. It's gonna be fine. Yeah. No, like in your case, you need to make sure that you always, check the output.
Yeah.
Make sure that you have like if you have null or something else.
But we will see like this is not like exception handling in Rust. We call like error handling, and we are just seeing that in the next chapter, because like the error enum is like very close to the option enum, and Yeah, this is just next chapter, and you will be all clear about error handling in Rust, and it will be more clear and
Okay.
more obvious why there is no need for exceptions.
If, for example, we read a file that is read-only,
Yeah,
and we write, we want to write a file doesn't exist, is it not an exception?
no, this is an error.
Okay, so
You have to,
error.
I guess you have to handle the case when the file cannot be read by once.
Yes,
Yeah.
but this is an error. This is not an exception that is raised that needs
Okay.
to be caught and that needs to be handled. No, this is an error that, okay, you need to deal with this error, but there is no try-catch mechanism and those kind of things. Everything is just errors and just different variants of errors. This is a error enums that you define most of the time in your program, and you have a predefined a variant of your errors that you can have, and everything is clear.
So if you find this basically behavior when the file is not accessible, then whatever.
Pardon?
You define the behavior when the file is not accessible, when database is
Yeah, you need to handle all the errors and so on. So that's why it's like
if it's not handled.
if it's not handled, you need to provide a default case. There is no like
It's not rolled to compile.
I mean, this is like the match statement we have seen. So when you have an error, either you handle the error. If you don't handle the error, I mean, the compiler will complain. It tells, okay, guy, you didn't handle the error. Okay, up to you to say, I don't give a shit about this error. But I mean, you have to write it. It's not like magically my program come explode at my face because I didn't handle that magical exception I didn't know about. No, this is not possible.
File knows about any possible issue and then informs you.
Yeah, that's what I kind of like with Rust is like there is no surprise.
Yeah.
I mean, nothing can just explode at your face like that, unless like some people are just unwrapping in the middle of the code. But this is a very bad practice. So, I mean,
Quentin,
yes,
I have a question. If Unwrap
tell me.
should not be used in production, what is the use case of Unwrap?
Just the unwrap.
Yeah.
So there are two use cases. One use case is in tests, which is totally acceptable because in tests you just don't care, and this produce like super, let's say, compact code. You don't care if your tests are crashing. This is not important. It will just crash your CI/CD. And this is maybe something you actually want to trigger test error as well.
Yeah.
So if you unwrap something that should not panic, okay, there is an issue. So it might be also a way to discover some issues. So in test, it's purely acceptable. Second use is, for instance, to optimize code where you already know the condition is satisfied. I don't know. I will give you an example. I have a structure with a vector that I try to access by index. I already know if you look at the get implementation, so to get something at an index in the vector implementation, in the vector definition, it gives you access to an item inside the vector, okay? But it gives you an option as a result, because if you go out of bound, it returns none. But if for optimization, because you know that you access an index which is valid in the bound of your vector, you can call unwrap. But if and only if, because you have strong checks before that you will not raise a panic. there are lots of code in the Rust standard library and in very well-tested Rust packages that do heavy use of Unwrap, but this is like super well-reviewed and tested code. And this is for optimization because unwrapping, basically the compiler does very few checks, and it's obviously faster than doing more complex checks. And the code, the compiler can optimize stuff when you unwrap, and yeah, these are the two usage. But to be honest, if you are not like a core standard library developer, don't use unwrap in your code. There are very few people, to be honest, I trust who are using unwrap in the code. So yeah, for I mean, people like us, we should never use unwrap. And yeah, there are a few exceptions. I have a project, for instance, where it's a parser, and the parser is like defined based on regexes. And at some point, instead of double checking, like unwrapping something I know which is there because it's validated by a regex, you just call unwrap and it's shorter. Because anyway, it should never panic since it's already validated by a regex. So yeah, this is implementation where you can use unwrap, but shouldn't definitely be used like in something that has like a huge how to say, in maybe like something web facing or stuff like that, something critical. You should never use unwrap in very isolated functions where you can determinately say that the parameters are okay and the values are okay. You can use, but it should be very isolated. So if you can avoid unwrap, don't use unwrap. I mean, just the unwrap parentheses. I mean, the unwrap variant are okay because it doesn't cause any panic. Just unwrap alone, this one. So this call unwrap without any variant. Should not be used, or very rarely.
Can unwrap be used also with structures?
No, unwrap, it's actually a method which is defined on option. So this is a method defined on option. So if you want to call unwrap on a structure, you implement unwrap for your structure. But why do you want to unwrap a structure?
No,
Or unless I'm missing your question.
No. I didn't want to mention structure, an enum, like the shapes, no? So triangle, square, getting the variant.
No, you cannot unwrap. You cannot unwrap unless you define an unwrap method that panics on whatever condition. But just remember that is what we have seen here. What does unwrap? It's this. This is the code of unwrap, basically. So it's just a pattern matching around enum type that panics on some value. That's it. And the value on which it panics in case of option, it's none.
So
this is what the unwrap method does.
So the option works only with scalar values?
No. It works with anything. It works with any type. This is a generic function, a generic type, an enum taking a generic type.
Okay, so if I
This is
define
defined like that.
okay, okay.
So T here might be anything. There is no restriction on T. You can have enum option of basically anything in Rust.
Okay, so I wanted just I was thinking loudly to panic on unwrap or no, sorry, on unwrap or default. If I define a
Yeah.
user, this variable
Find
is
what?
this variable is some user, so the
Yeah.
structure. And then I do unwrap or default. What is the default of user if it's not?
If you didn't implement the default method, it's gonna complain.
Okay.
If you derive the default trait, which should work, maybe it will provide you empty string for password identifier and none for the age, because the default value for an option is always none. So it might work. We can create some user here, for instance. We can call optional user, okay? And it's some U1, for instance. Okay, it works.
U1 means
It's
okay.
this one. So you see what the compiler does under the hood is taking the user type and generate the option implementation for that user type.
Yes.
And that's how generic works. It's basically, you have to see that when you see like, I don't remember how we call these. Anyone knows?
No.
Like these brackets. Square brackets? No. Greater than and lower than. Okay, anyway, when you see that, when you see that, it means that it's a generic and it's going to be implemented by the compiler for any type T. And it's when you use it, don't need to define it. When you use it, the compiler generates all the implementation. This is a template. Okay? I don't know if that is clear.
Yeah, yeah. Now I just wanted to know if I do unwrap or what's happened.
Unwrap or
Default.
default, it's not going to work because
Okay.
optional user has no default. If I
Yes.
do unwrap or default, it's gonna tell me there is no default implementation for user.
Okay.
Basically,
So if we create a
option
custom,
one user std default is not satisfied. So if I would like to, I have to derive default here. And this is going to work. And it's going to provide me like the default implementation for user.
derive.
What is it complaining about? Yeah, it tells me that I'm unwrapping on some, so I'm stupid. So but yes, if it's like if it would be none,
Of course, it will panic. No.
No, it will not panic. Unwrap of default
Yeah,
doesn't
yeah.
panic.
Yeah. So with derive, you say that if there is no user, the values should be default.
With derive, I say I provide a default implementation for user type. That's what I do with the derive.
Where did you provide it?
It's the job of derive. Derive is actually generating code for you. I don't know if you were here this morning when I explained that, but this is exactly the same thing as implementing a function by hand, except that it's the compiler who does it for you. It's just like super short,
I was not there.
and it provides a default implementation for that structure.
Okay.
At the only condition that every member of the structure has a default implementation value. So identifier string as a default value, which is empty string, again for password, and option as always none as a default value. And what does it do? Say, unwrapped user. And this like should provide the default value of user. What is the issue? Yes. Because there is no. Okay. You can verify. This is the default user. Okay?
Okay.
Is that clear?
Yeah. No, I wanted just to know if, in case we create our, let's say, variable types, we should always foresee a default value if we want to use unwrap or default.
Yes.
Okay.
So safe unwrap, we covered interesting thing. The question mark operator. So this is very important too, because this is something you will see everywhere. It's a shortcut for handling options. So it does two things in just one character. Again, this is to create very concise code. If the option is sum, it unwraps the value. Okay? If the option is none, it returns early from the function with none. So when to use it? When you have a function that returns option, and when you want to bubble up known cases, and this avoids like nested matches statements, and it produces like a lot of super compact code. So it only works with a function that returns an option, and it makes the code very clearer and safer than unwrapping. So let's see something. What is find first even number? Okay. So the square first even takes a slice of I32 and find the first even number and returns it, right? By using the first find first even number, we iterate over the slice, we check if it's even, and we return a number, some number. Why do we return an option here? Because in the slice, we don't know, maybe there are only odd numbers. So we need to handle the case where we don't find any even number. That's why we return an enum, an option. So this method, what does it do? It squares the first even number we found. So this is called banana. I don't know why. So we find the first even number, we take it, we put it in a variable, okay? And then we square it. So here we should square 2 and square first even equal should be 4, okay? We all agree? That's what we do. And it's actually sum 4 because this method returns an option. So you see, this might be a bit cumbersome. And the proper syntax and the thing you will see in Rust would be like that. And this is exactly the equivalent code. So we use find first even number. And since it returns an option and we also return an option, we can use the question mark operator that will, if this method returns none, will return early none. And if it's an option of sum, we'll basically unwrap the value and assign it to n. This is the exact same thing as here. You have to see this stuff exactly the same as this. So you have one character versus 1, 2, 3, 4 lines of code. And yeah, this is something you will see a lot. And in this example, might not like be super obvious how to use it and why. But trust me that in big functions, instead of like doing match statement all over the place, just putting question marks is very how to say comfortable.
It's a safe thing.
Pardon?
Safe. It's yeah.
It-
you know, Rust is safe anyway, but
It doesn't change anything about safety. It's just like code brevity, and yeah, in the end, this like is like only one line is really useful. Is this one? The rest is we don't care. So this is just like shortcut. This is interesting because this operator is going to be applied also on errors, and it will be you will be able to bubble up errors very easily without very complex error handling. So yes, just be familiar with this notation, with this syntax, because you will see it really a lot. So is that clear for everyone what this question mark does?
And it's only working if we set the return type to be option.
Yes. If I change the return types, it's not going to work. And probably it's going to work even though I want to return a different option type. So if I want here to be F32 instead of U32, it works too. You just need to have like option. Okay, it doesn't mean like you need the exact same option type. No, it's just it works with any option kind basically. So it does the conversion between the known types also of the different option variants. That's where the power is, because otherwise you would you would need to handle different match statement and producing like weird a lot of code, useless code, basically.
It's the same for parameters.
The-
We expect optional parameters for the method, for the function.
Yeah.
And
This question mark, you can use it everywhere where you have an option.
But for it will not for virtual. If numbers this will be optional instead of number, you'll put option.
Yeah.
Because it will parameter.
Yeah.
Or you can copy.
This
Yeah. Like that.
this is very bad, by the way, but
Okay.
because a slice might be empty, so you don't need option, but
Ah,
I just mentioned it. It's useless to put option a slice, but
if you put question mark after numbers, will it pass none inside of find first even number?
there,
Yeah.
no. If I do that,
Yeah.
if number is none, it returns none early.
So it will not pass
No,
parameter none to.
no. What it does under the hood is that because this we could now call it op numbers, okay? To be exact.
Okay.
So if we would have numbers would be op numbers question mark, and this what it does, it unwraps the slice or return early. Okay?
Mhm.
So this is exactly like that. It's just a shorter notation that
Mhm.
this does exactly the same as this. So here, if there is none inside, you return early. So you will never even don't reach this part. And now it's not happy about this, of course. Is that clear?
Mhm.
Is there like a good or bad practice of using options?
No, yes, I would say using options with stuff that can be empty is a bad practice, I would say, because it's kind of a double purpose, because any container that can be empty doesn't really need to be none or something. You can just pass the container and check if it's empty or not. This is a bad use of option. This is a bad use of option, okay? And anything option of a container, I think it's a bad use of option.
But for example, in the square first even, you could return 0 instead of none. No?
Why?
Um,
0 is not the first even number.
mm, mm, mm,
And 0 is not the square of the first even number.
mm.
So none is actually to serve that purpose of not using like default arbitrary values. That this is actually what you do in C, in C++, in Go. You often like return nil, which is like close to null in C. But yeah, this is actually the purpose of option is yeah, make the get rid of null and basically arbitrary default values for stuff we don't find or stuff like that. Okay, so that's it. This was a good question, like the good or bad use of option. Yeah, just remember anything container, no need to put like options around it. It serves no purpose and make basically redundant code.
Yeah.
So if, yes, in this case, instead of putting the options, you could do, if you want, if numbers is empty, And this way you would never reach this call if it's empty. But in the end, you will not like win a lot of performance with just adding this, because this is this would basically, the for loop will do nothing because the stuff is empty, so it will return none. So yeah, I mean, this is not like heavy processing, so just adding this check wouldn't you wouldn't win like a lot of performance. It could in some circumstances where this would be like intensive function, but if you want to check containers instead of options, do like that. Most of the containers in the standard library, so you have the vectors that we have already seen, used to be contiguous types in memory. You have hash maps, you have B-tree maps, which are maps organized as binary trees. You have vecdq and so on. All of them have like emptiness checks. So this kind of a standard method for containers. So never use options with containers.
Can I ask
What
a
I
question?
mean, tell me.
Let's say, I'm just thinking, let's say that these numbers come from a stream. You don't know what is the stream, and sometimes you have
Ouais.
no number. How would you manage this? To put option in I32 or
Numbers?
yeah, let's say that it's coming from a stream, external stream. So you have an array
Yeah.
with numbers, or sometimes the number is none because it's not a number. How do you manage in this function to avoid to be in panic?
This is that. Like an empty slice.
No, I mean just
What do you
one of
mean?
those numbers is none. So you receive, I know,
No,
three,
this is
one.
not possible.
Ah, okay.
This is not possible in Rust. Because, okay, what is the use case? Is like you deserialize stuff and you realize it's nothing?
Yeah, sometimes.
What is the exact use case? Because there, this function, you can call it only with the I32 slice. So there is no way you call this method with a slice of options I32. It's not going to work.
Okay.
So you want to handle the case where you need optional I32, okay, no problem. You put option I32 here. And
Yeah.
then you have an option of I32, except that find even numbers will need to be adapted. So what do we need to do? This would need to be an option I32. Then we iterate over option I32. Okay, no problem. How do we handle that? We have seen if let
Yeah.
some num equal num, we will rename because there it's weird. So and now we have handled the case.
Hmm.
And there as well we need optional I32. So here we have a method that takes
A stranger.
that does exactly what you want. But now we have to do some 3, some 1,
Ah, okay, okay.
some 9. We can put the known in the middle if we want, and some 2. Okay? And the result should be the same, right? Should always be 4 because 2 is the first even number, right?
Yeah.
Okay. Some, damn it. So yes, this should work. So where is the one? Okay. First even short. This one returns none because there is nothing. Okay, but now we have handled a case where you can have a non-I32 in your, let's say, stream of integers. But yes, it needs to be implemented like that. It's no way you can have known values popping up like in a stream while the function cannot handle it. This is not possible. Because yes, anyway, if you want to see that in practice, it would mean that yeah, this stream of integer comes from somewhere. It needs to be some kind read, deserialized or something like that. So I mean, the value at the moment where it's passed to this function needs to be known, you know? Needs to be known, not none, known. Okay. Is that okay?
Yeah.
Clear? Not too confusing? Confusing?
There are many new things like this passing by reference always, like doing this. Maybe not the most confusing thing, but
What is the most confusing?
oh, the finding in general.
So now maybe we can move to the results, which is kind of close to what we have seen with the options. This is a new enum that you are going to see everywhere in Rust, and this is the way you handle errors. And this makes like Rust exceptionless. So it's the way of handling a successful or a failed operation. So it's an enum again with two variants, but each variance can carry a different type. And that's where it might become confusing. You have one type for the OK message, let's say when it's successful, and one type when it's an error. So the result enum makes error handling very explicit. You must always handle both the success and the failure. You can use the question mark operator as it was with options. Instead of returning none, it just return error. And yeah, basically, you will never ignore errors, unlike exceptions in many other languages. I don't point any language here. So a way to imagine results, it's a box that contains either a successful result, so OK, or an error message. This is like simplistic. Let's say we have a function which is handle positive number and takes one number in parameter. If this number is positive, you return this number in question inside a result variant, OK. And if the integer is not positive, so negative or 0, we say we return a result of error variant, and we put like a string inside, which is we expect a positive number. And we need to define like the return type of this function. And we need to define the always in order the OK type. So the OK type in our case will be I32. And the error type will be a static string. And so what happens if we run the handle positive number on 42? It's going to tell us the result is OK 42. That's what we wanted. This is positive. We have an OK variant of this enum. So now let's try to do the same, but with a negative number. And we see that we get the error variant of this result enum. And the thing we get inside the error variant is a string, a static string, which says we expect a positive number.
It's not terminating the program.
No. No, it's just giving you a way to handle the error. Up to you to terminate the program. If you want to panic on an error, up to you. A very bad practice, but you just bubbling up errors all the time. That's what you do in Rust, and then you do whatever with the error. Either you handle it or not, but or panic or whatever you want, but there is no arrow thrown or whatever.
Error type, something, or just error, or we can define it. Make it,
Yes, you can. We will see that later. Don't worry. Okay. So the thing which might be confusing at this point is maybe like this double generic use, right? Isn't it too complicated? Like the T and E.
It's like a common, I wrote it on the doc, like you use T to define the type, a common type,
Yeah.
E for error.
Yeah, T is like the error, the type for the successful, and E is the type for the error. It needs to be different because why it needs to be different is because in this case, you could have put like I32 as an error message, but I mean, as an error value, but what does it say? Nothing. So this is why you need two different types. And this is again kind of templating over the result enumeration.
Does the type of the error should be always defined?
A string? In Rust, everything must be defined. There is no like undefined. This is not possible.
Yeah, so now I mean I should always define in the function declaration that it will return a string or something else, right?
Let me let me see if I cover this later.
Okay.
Yes, I cover this later.
Okay.
This is like a super simplistic result handling. This is not reflective of what you will necessarily do in practice. Some exceptions made, okay? Because returning a string is not very optimal. What you would do in practice is you would return enum error enum here. That is very, very frequent. The error type is an error enum, and in your error enum you encode every different error that your program can have or your function can return. Is that answering your question?
Yes, no, because I just wanted to know if there is a default, by default a string, so I should not have to declare every time I write a function, just this.
This, because you are concerned about this?
Yeah, I mean, if I write result I32 stop, then if there is an exception on this.
Yeah, you can do that. If this is what concerns you,
So it assumes that it will be a string.
this is just writing this ugly stuff all the time that is
No,
bothering you.
okay, but God, for this I know.
You could do that.
Yeah, of course.
No, I think he wants to know if you can put any type, like if you can put nothing in it and it just guess.
No,
No.
there is no guess in Rust.
There is no optional
guess.
generic. I would say.
There is no what?
Optional generic.
What is an optional generic?
So a generic that
Describe it to me.
if it's not defined, it's a string, for example.
No.
Okay.
No, this doesn't exist. Always explicit in Rust.
Okay.
It does nothing for you. Unless it's very clear and everyone agrees about it, but maybe you could craft some like weird results that does what you want, but this is not something that is commonly used, let's say.
Yeah.
But there is no such thing in the standard library or in at least grades I have seen so far. So let's move on with the question mark operator. This is the same ID than for option. So this is the shortcut for error handling. So if the variant is okay, you just unwrap the value, and if the variant is an error, sorry, you return the error early. Exactly the same as with the option. So again, it only works with functions that that returns results. And yes, it makes like error handling super short and much clearer. So let's see. Okay. Here, handle positive number, same function as above, you square the positive number. So square positive number, handle positive number, see if positive number is okay, we put it in num, otherwise we return the error, and finally we square it. Okay. When I is 42, it works as expected. When I is minus 42, we return early an error because we return here. So yes, we can create a function that does the exact same as we did with the option, but using the question mark operator. Because this is just like manual implementation of question mark operator. So this is no more complex than this. Why is it unhappy? Because I still have the match, yes. So again, one line of code instead of 1, 2, 3, 4. We win 3 lines. Okay, we are almost done with the timing. Is that okay if we finish that chapter or yes?
It's a question about this static.
Yes. About what? The static?
Static, yes, this syntax.
Yeah.
1%, then it's whatever it's. I mean, you told it it's kind of the time frame.
The lifetime?
Life. But why do you need it? Is it to unlimit time or lifetime?
We need to put it because the Rust compiler needs to know when you return a reference from a function, it needs to know the lifetime of that reference because of dangling pointers and so on. And because in this case we are using a string and this is a literal string, I mean, which is like valid all the time, which is always the same, we put the lifetime static so that we know the compiler will be happy about it. And actually, yes, this is a static string anyway. So if you look at, this is just the return type of the thing we want to return. Because this is a static string, so we put like static string here.
Lifetime as you did A, B, or something.
Yeah, but there is for string slices, literal strings, it's always static lifetime.
It's a special lifetime static for.
Yes, static is a special lifetime, yes. This is a lifetime you cannot like use, this is not an arbitrary lifetime as you would define A, B, C, D, whatever. Static is a reserved keyword of the Rust language. It does know that this is like something which should be valid during the whole lifetime of the program. Static, that's what it means. It means this string is valid during the whole time this program is running. So this string is like always in memory.
Doesn't it affect the performance
What?
to have static string
No,
that stays during the whole script?
no. I mean, it's like that in a lot of programs. It's just that many programming language they make abstraction of this, but
in terms of maybe
But
the
it's
performance, but
it's not passing the exact string if you return reference.
yeah, it's even yes a reference. So I mean, this like is a memory address in the when you actually use
And it's stored.
assembly code. This is just memory address, so it's very few bytes.
Yes, yes.
So this does exactly the same. Let's do it. Shorter. Okay. So question mark does exactly the same. And this is fun because look, if I remove this, what it tells me here, this match expression can be replaced with question mark. So Clippy is pretty smart. He knows that I'm just re-implementing the question mark. So again, it tells me I'm dumb. So yes, we have some common points and with options, which means results also have like unwrap methods, so which panics in case of error, again avoiding production. You have unwrap or exactly the same as options. You have map, which transforms, but not like the sum value, but the successful value. You have the and then that actually it can be used to chain operations on case of success. And you have like calls like is okay, methods like is okay or is error if you just want to check if it's a success or a failure, basically. So these are examples. Here in the first calls, we check is okay, is error. Here we are for both. Here is always okay value because this is a positive number. Is here it will always be an error because we try on minus 42. So we are going to unwrap or default value. So here we expect to be 42. Here we expect to be 1337. You can map and square the results with the map call, and we can try to unwrap and see what happens. So here we test is error is okay. Okay, res okay is okay, is not an error. Res error is not okay, it's an error. Here, res okay, we unwrap, or we should get 42 because it's not an error, so we don't use the default value. Here, the result is an error, so if we unwrap, we should take the default value. We take the default value. Here we square the results of the OK value, which is 42, and this is the square of the OK value. And the map here on the failure, just return a failure because map only process the successful value. And when we unwrap a successful value, we get the wrap value inside the OK variant. And we can try to unwrap on an error. And what are we going to get? A wonderful panic. Tada, as promised. Okay, if you want to handle your error like that and panic, up to you. but yeah, it shouldn't be done like that. So, okay. So in practice, results enum is used for proper error handling. And most of the time, you don't use like simplistic error type as the string as I define. You most of the time have error enum where you define all the error variants that you want your function to actually all the variants that your function can return, and then you are using that. This is much more adapted to the use of results. So in our case, for handle positive numbers, we can imagine two different kind of errors. We can handle the case where I is actually 0, and we might return an error like is 0, and we might have another error kind, which is when the I value is negative, and so the error would be is negative. In this way, if we do that, we get the chance in our, let's say, the caller of this function to handle both the cases differently. We might want to do specific processing in case we get error is 0, and another specific processing in case the error is negative. So we can see this in action. So here we call handle positive number with I being 42, with an integer being 0 and 1 being minus 42. So this should return a result OK value of 42 because it's positive, no issue. This one should return an error is 0, and this one should return an error is negative containing the negative value. Because that's what is nice, combining like results and error enum as error type, is that you can also carry some data in your errors and bring context to your error management. So, okay, input 42, result okay 42, input 0, we get error is 0, and input minus 42, result error is negative. So we kind of get what we wanted. And in practice, what you would do, you wouldn't just call this like that. You would say, I don't know, match handle positive number of whatever integer. It could be like a string integer you parse from somewhere or whatever. And then you do some specific processing. You do okay, okay. We'll actually do that because this is confusing. And error. And what is interesting is that you can either do directly destructuring here and do error is 0 like that. If you want to handle all the cases, so you could do that, or you could actually do something like that, and then do a match on the error, which in the end does the same, and handle every single error variant. Up to you. This is exactly the same. If you prefer nested blocks or not. I know it's a lot of information. So
And we could have a default return in case it's none, for example. Yes.
here there is no none. This is not possible to have none here because we have no option. But yeah, I mean, you can do whatever you want with an error. I mean, here you can print, you can return, you can do whatever. You can even modify some stuff. I don't know. But this is just to show you how actually you handle errors in Rust, and the fact that you need to be some kind of explicit and handle all the possible cases. And what is nice is when you define your APIs like that, it's like, okay, user says, okay, this function returns error. What error is? Okay, error can be is 0, is negative, blah, blah, blah. It's always like super descriptive. And I mean, there is no surprise again. If you decide not to handle one error, okay, it's up to you. You cannot blame on the language or the guy who implemented or whatever. It's just up to you to decide to manage an error or not. So it's I think it's pretty clear how you should handle errors. And yeah, there are some, this is a very simplistic use as well, because we make the assumption here we call only one function, but there are ways to really bubble up errors across APIs. So in the end, in a library, for instance, you have only one error type, and it can be like several kind of errors. This is actually how you do. And for instance, what you would do, I don't know, if that function, assuming that function would process some IO, input output, some files, we would add a IO error, which would be std IO error, and then we would actually on error on an IO file put like the IO error inside, and this would be all the possible errors for my implementation, which could wrap a type from another error. And that's how you manage like the interdependency between the error types that you may have in different crates or packages or modules or whatever. I think it was kind of intense. No?
A bit.
Okay. Are you guys, do you guys, the remote guys have questions?
I think I'm good. Again, I will need to like play a bit more with it, but like I think on my side it's fine.
Okay, good. And I think before the last sessions, we will tackle so generic and traits, and maybe the last little projects. Maybe I say it for everyone. For the last sessions, if we do it remote, I got like some feedback from the guys of Circle who wanted to see, for instance, how to integrate Rust with Python and have like a really specific use case for that. So if you guys think about stuff that could be interesting for you, I don't know, create project, manage projects, see other stuffs. Maybe just think about it and we can create some sort of list and we will try to do it during the last session, even if it's remote. And eventually, anyway, we will record it and you will be able to see it. No. Yes, yes, yes. We can do that, but that's already advanced, I would say.
And about networking, like client server.
Yes. What kind, like HTTP client, HTTP servers?
Some basics.
So
Echo.
So yeah, there is one thing to know with Rust. It's that even though like the standard library is super well furnished in terms of structures and yeah, all the basic functionalities, iterators, and so on. All the rest, like HTTP databases and so on, all the rest is like external. So it's like external projects. So we can obviously see some use cases, but it will be tied to a specific, like, how to say, framework that other people have developed. So, yeah, it might not be like relevant for everyone. So, yeah, HTTP servers, there are, I don't know, maybe 3 or 4 very well used projects for that, for doing web APIs, some having pros and cons, and yeah, everyone having basically pros and cons. So there is no one single way to do that. So basically, yes, it's using a specific framework, external library to do that. Of course, the standard library probably has some basic networking functionalities, even though I doubt. Maybe.
Maybe it would be more interesting to use the standard library than external modules or
Yeah.
just
Yeah.
to understand.
Python, let's say Python bindings, it's a bit different because I would say that there is only one library to do it very well and super easily. And it seems to be kind of a consensus, like everyone is doing it. It's called PyO3. And yeah, it's really super simple interface, Python bindings that you can create for your Rust code. In a few lines of code, it's done, and you can use actually, you call the function from Python, and under the hood is actually Rust compiled code which is running, which makes like faster, let's say, Python and faster implementations. So yes, I think in Circle a lot of people are interested in that because we have lots of Python developers. But yeah, maybe we could.
Maybe async and multiprocessing.
Yes, we could do multi-threading. Yes, this is possible. We could see how to do it. But yes, we would have to use also an external crate for that. There are not a lot. There is Tokyo, which is for asynchronous operations. And yeah, this is something we can do. But this is also a bit advanced because we really need to understand deeply all these concepts of ownership and so on, because the borrow checker and so on is going to complain a lot if we don't do things properly.
Would be a good exercise for ownership.
Actually, I think in the Rust book, the last project they ask you to do is kind of doing a HTTP server or something like this. So, but this is the Rust book is like 20 chapters, and yeah, here we cover maybe, I don't know, half of the chapters. So maybe, yeah, the idea is not like to frustrate you, and so that you can maybe start on a small project and start. I don't know if like people want directly straight going into and so on, but of course we can do multi-threaded programs and so on. There is no with that. The only thing I just don't want you is I don't just want you to be frustrated. So, but yes, we could definitely do something like this. What did I put as a project? Yes, it's a simple data structure. So, okay,
Yeah, thanks a lot. Thank you.
good. I'm stopping the recording and I will stop the meeting. So see you next time, guys,
Yep, see you.
Bye. Thank you.
on Friday. Don't forget.
Yeah.
Merci.